Welcome, everybody. I'm from the CCmath office here in Amsterdam, or actually quite in Amstelveen, quite close to Amsterdam. My name is Koole. A number of you I met before. Some of you I know very well, and also to everybody who is new to these webinars. Welcome. As I said a few minutes ago, this session is being recorded. Feel free to interrupt, say something, but be aware that we record this session and this webinar together with or other webinars is put on our website for you to view them, but be aware of the fact that whatever you say will be part of the recording. Okay, today's subject is WAPE. A few days ago, it was King's Day here in the Netherlands, our national holiday, so therefore an orange crown. But I want to forecasting is more than coming up with a forecasting model, producing forecast. It's also about measuring forecast, and WAPE plays an important role in that. And I want to tell you a couple of things about that, and towards the end, I will also try to make it very practical. We actually have a simple Excel add-in that you can use to do the things I'm going to show you yourself. WAPE. Okay, so what am I going to tell you? First, I'm going to tell you why do we think the WAPE is the way to measure error, forecasting errors. So that really is what's in the title. Then I'm going to say a few things how to use WAPE, and then again I'm going to tell you well, how to do it yourself. And I really think there are multiple ways. They're all pretty easy. And again, we made an add-in to make it really easy for you. Okay. Well, in the first place, why do we need something like WAPE? Why do we want to measure forecasting errors? Well, sometimes we have discussions with people who say, well, why do we need a good forecast? What is the added value of a good forecast? And if you have a good forecast, and of course you do your scheduling steps accordingly, then you have little under or overstaffing. Yes, your staffing, the number of people you scheduled is exactly or almost exactly right. So you have little under or overstaffing. And if you have little under or overstaffing, that means also that there's no reason to adapt anything. Of course, if you have a lot of under or overstaffing, that means that typically in your intraday management, you'll have to adapt for that. Yeah? So I hope and I think most of you will be convinced of that, you need a good forecast is helpful for a stable scheduling process and less intraday management. But how to evaluate the quality of your forecast? So you want to, as a forecaster, you want to be able to report on the forecasting errors, and how to do that in the best way, how to measure it. Well, and that is WAPE is one way to do that, and I hope that by the end of this webinar, you will be convinced that WAPE is the right error measurement. Let me just, let's just take some example data. So here in blue, you see a forecast, and it's a nice smooth curve. So I think this looks like a good forecast, and actuals. And I think that you will agree, if you look at the actuals, that the forecaster actually did quite a good job. Now you ask to a statistician, can you tell me how good is this forecast? Yes? And a statistician will often come up with something like the root mean square error. Yes? And some of you were probably statistics, or you followed some statistic courses. Perhaps you know about linear regression, then you know that linear regression will minimize the sum of squared errors. Now, in this particular case, the root mean square error, and I'll explain what it is later on, but just as an illustration, is in this case is 9.4. But what does this 9.4 mean is this the average deviation from the forecast per quarter? What you see here on the horizontal axis are quarters in a day. Well, actually, that's not the case. So this number, which is quite often used, this RMSE, it doesn't have a good interpretation. So being interpretable is one of the things you want from the way in which you measure your errors. And that's not the only thing. Of course, you want it to be easy to compute. And preferably, and I'll explain you more about that in a couple of slides. You also want somehow that it is related to your objective. Yes, because you have reasons that you want a good forecast because you want the rest of the process to go smoothly. So how can you translate the objective later on in your scheduling process back to your objective of your forecast? And that might be a bit vague right now, but I hope that will become more clear in a few seconds. I will talk about a couple of candidates. If you dive into the literature and if you start looking for root mean square error on Wikipedia, then you'll find other things like MAPE, WAPE, MACE, MAE. There are lots of others around. Sometimes they're similar, sometimes one can be converted in another. Actually, I'll focus on the root mean square error, MAPE, MACE, and WAPE. Actually, the MAE, the mean absolute error, does the same thing as the WAPE. If you need more details about that, it's important to know a bit, of course, these abbreviation. If you talk to a data scientist or a statistician and they come up with this abbreviation, then it's of course useful that that you can talk to these people that you understand what they say. But I'll focus on the three here: MAPE, MACE, and WAPE, and RMSE. And here the abbreviation. There are lots of abbreviations. Well, case in any domain, same in statistics. In MAPE and in WAPE, you see there is something which is called the absolute percentage error. Now, some of you might be aware of what it is, but let's do things step by step, and let's take a look at what is this APE. Yes, the absolute percentage error. Well, what is it? Pretty simple. That is for one interval. The WAPE is for longer time periods, for multiple intervals, whether these are quarters or days. Yes, but if you look at one single interval, then the absolute percentage error, well, basically what it says, you look at the absolute error, forecast minus actual, with these bars, they mean the absolute value. So if that's negative, then you, you take away the minus sign and you divide by the actual. Yes? And that is the definition of the APE, absolute. The order is actually, it's like percentage absolute error, but APE sounds better and it's basically the same. Yes, so the absolute percentage error. As an example, you have a forecast of 100. Yes? Then it turns out that the actual is 110. No matter if that is a small line during the day or a quarter of a somewhat bigger queue, doesn't matter. Yes. Now you fill in the formula, forecast 100, actual 110. Then you see that the error, the forecast minus the actual, your forecasting error is minus 10. But you take the absolute value of that 10, you divide over the actual, not the forecast. The actual is the ground truth on which you base yourself. So you get 10 divided by 110, and that's around 9%. Okay, so that is the absolute percentage error. So this is an easy to interpret. There is, however, if you ever use the APE somehow, there might be a small problem, and that's especially the case if you have a very small queue, which happens definitely here in the Netherlands, in Europe, where sometimes you have multilingual call centers with low volume on on rare languages. Hey, you might have a call center which is open during the night with very little volume in the middle of the night. And then it might happen that the actual is 0 for one or more intervals. And then you right away have a problem, because then in your definition of the APE, you divide by 0. So that is a problem to keep in mind, because that complicates certain of these measures. And statisticians actually, they came around with all kinds of solutions for this division by 0 problem. And actually, if you think of the MAPE, and the MAPE is the mean absolute percentage error, that's simply the APE over multiple intervals averaged. And then you right away might run into this problem, because if you have one interval with an actual of 0, then well, I learned at school division by 0 is nonsense. So then indeed you get an error. In Excel you would get a div by 0 error. But that's not the only problem with the MAPE. And what is another problem with the MAPE is that it magnifies errors if you have low volumes. So indeed, suppose that you have 24 operations with a very small volume during the night and higher volumes during the day. Then the errors during the night, because the actuals are also low, get amplified and get a lot of importance, and that is probably not what you want. So here I took an example, very artificial example, not based on real data as the previous example. Here you see a call center, and let me explain the figure. Perhaps it's a bit small, but I hope you can see it. You see blue and red bars. These are the forecast and the actuals. And actually, I assume that the forecast is 10 during the first number of periods and 100 later on. And then I use some typical fluctuations. And then what you see is that the percentage error, the absolute percentage error, the APE, is much higher during these low volume periods. Yes, there is noise going on. Today, I'm not going into the details of the noise, but those of you who are a bit familiar with underlying processes, that is Poisson noise here. And you see that plays a bigger role in these small volumes. So these errors, and that is in green, these are the percentage errors. On the right, you see the percentages, the scale. That can be pretty big. And what you see, if you look at the MAPE, so the average of the errors on the first half of the time periods, you see it's 36%. It is way lower on the in the second in the other intervals, second half, but overall it's 20%. So, and that is so high because of the low volume. But I mean, how important is it if during a quarter you expect 10 calls and you get 7 calls? That is not so bad as in the situation where you expect 100 calls and you get 70 or 130. Yeah, so the consequences of a forecasting error in high volume moments are way more important than low volume moments, and that should be reflected in your error measurement, and that is not the case in the MAPE. Yes, so these are 2 reasons why the MAPE, which is by itself a very simple and easy interpretable measure, is not such a good measure. A few words on the MACE, and that's basically also because people talk about it. Of course, forecasting is a scientific field, part of statistics, can be very mathematical, can be way more practical. There are 2 people out there in the scientific field which are known as general forecasting experts, which are also known by somewhat bigger audience. Makridakis is one of them. He was a professor at INSEAD in Paris. He's retired by now, but he set up forecasting competitions. If you're interested, go look for M competitions on Wikipedia. Another person who is younger, not retired yet, I guess around 50, Rob Hindman, he's an Australian, very active also in this field, wrote a nice book online available on forecasting. Do have a read of it. It's free. And he introduced something which is the MAPE. And one of the reasons he introduced that was to avoid this division by zero problem. What he basically does, he compares a naive forecast, and a naive forecast is really a forecast without seasonal effects, without a very simple forecast with your hopefully better forecast. Yes? And then he takes the ratio of that, and that is basically his MAPE. And that has certain advantages. However, well, it is really hard to interpret that in terms of, has something that makes sense in the call center. So I think this is less relevant to call centers. I did want to mention this because people are aware of that, and if ever you go into discussions, people might ask questions. The last one, and that is of course the one where I want to focus on, is the WAPE. Now I told you for the MAPE that you have this problem that it gives a lot of importance to these errors of this low volume. And you can prevent that by weighing the errors, the APEs, according to the volume. So you give more importance to the errors in high volume and less importance to the intervals with low volume. Yes, and that is what the definition of the WAPE is. And so the big advantage is that small volumes play a lesser role. Now here are the formulas. You're probably not all very familiar with the mathematics. So if you do not follow this slide, no problem, you'll catch up 1 or 2 slides later. But as you might see here, you see here the APE, and then the MAPE takes the average. So we have capital T intervals. So you divide this APE by capital T, nothing else. Then the mean you sum and you divide by the number of numbers that you sum. That's it. That is the MAPE. In the WAPE, you, instead of giving every data point, every interval the same weight, you give a weight proportional to the volume, proportional to the actual. Yes, that is the definition of the WAPE. Now, of course, you don't, well, it's unless you want to implement it yourself in Excel, but in principle, you do not have to know this formula. But the interesting thing is, and here's a bit of mathematics, so I hope you can follow me. But if you look at this, and here I rewrote this definition, as you can see in the numerator and the denominator, there's this same AT, so they cancel out. And actually, you get this formula here. And this is a nice, simple formula, because here it says, this here on top, it is the sum over the absolute differences divided by the total volume, the total, the actuals. So that is a very simple formula. So actually this WAPE can be rewritten in a very simple formula with as advantage this division by A here of the MAPE has disappeared here. It canceled out. And that was the problem of this division by zero. So there's no problem of division by zero in a very simple formula. To put it in Excel, some of you are probably very familiar with Excel, to make that perhaps even more clear that is really these two formulas are the same. And again, if you don't follow this, this is you'll catch up on the next slide. But here I did the calculation using the weighted APE. So here in this E column, this is really the APE, but in Excel. So the difference between the forecast and the actual, absolute value of that divided by the actual. And then, well, you have to weigh according to the actuals. And weighing in Excel is a sum product. So here, be aware that I have a decimal point. So I have a separator, comma. Perhaps if you're European, then you might have here a semicolon, but that Excel will tell you or give you an error if you do it wrong. But here I have a sum product between the actuals and the APEs, and I divide by the sum of the actuals, and then I get 12%. And now if I do the same thing with the the sum of the absolute errors. Here you see 84 minus 91.6 absolute value. These are the absolute values. Very simple. And if I take the sum of these and I divide by the actuals, then indeed I get the same answer. So it is really, well, pretty simple formula for the Okay, so again, sum of absolute errors divided by the total volume. Let's now make the connection with the staffing. Yes? Let's think about the following. What are the costs of a forecasting error? And let's do the following thought experiment. Suppose that you're no shrinkage, you're in a setting where your average handling time is 5 minutes. You're scheduling at the 50-minute level. Then if you make an error in your forecast of 3 calls and you scheduled according to your forecast, then of course, if you have an error of 3 calls, that basically means 3 times 5 minutes is exactly the quarter that you're under or overstaffed, depending on which way your error went, by 1 agent. Now suppose that you make an error of 6 calls. Well, then you're under or overstaffed by 2 agents. Hey, but the WAPE is this sum of these absolute errors. Yes? So if your WAPE is twice as big, that means, well, that you have to do twice, that you're over or understaffed twice as much, and that you have to do twice as much real-time management. Yeah, so the real-time management scales with the WAPE. If your WAPE is twice as big and you want to repair the staffing, then you have to do to schedule more or less twice as many people. Yeah? So the real-time effort and your cost, because that costs money and effort, your costs are linear with the WAPE. Yes. So and this is important in the sense that your WAPE tells you something about how much effort and how much money you have to put in the real-time management. And this was this has also been proven mathematically, and I worked on this with a PhD student a number of years ago. As some of you might know, I also have an appointment at university, and we try to solve some of the more theoretical problems, and this is one of the problems we tackled. Okay. Let me summarize this a bit theoretical part of the presentation. So we talked about 4 different measures: the root mean squared error, the MAPE, the MACE, and the WAPE. Here I summarize them according to the 3 criteria that we use: interpretability, the ease of calculation, and to which extent it's related to the staffing, to the overall objective of the call center. As we saw, the root mean square error is hard to interpret. There is these squares, and mathematicians like these squares. They have all kinds of nice properties, but it's hard to interpret. It's very easy to calculate. I didn't do it, but you simply take instead of the absolute errors, you take the squared errors, and then you take the mean of that, and then a square root. So that is easy. No direct relation to call center objective. The MAPE is easy to interpret. It's really the mean absolute percentage error. Because of this division by 0, there are some problems in really calculating it. It's easy to calculate, but then sometimes you get an error and you have to do something about that. Well, because it magnifies these small errors in low volume moments, it is not really related to the overall objective. Well, the MACE, I really think this is not an appropriate measure in a call center, and the WAPE satisfies all these 3 criteria, and that's why I think and we think that the WAPE is the measure to take. Okay, now you want to, if you say, okay, I'm convinced and I want to use it, well, what do you have to think about? 2 things are important. The first one, at what level do you apply WAPE? And do you apply it at the day? Do you apply it at quarter level? Well, that depends on the situation. I think you should use things in a certain way. And there's a goal why you want to have a good forecast, why you're forecasting, and that goal should be reflected in the way you use the WAPE. So if you do short-term scheduling, yes, you want to have the right forecast at the quarter level. So you probably also want to calculate the WAPE at the quarter level. Perhaps in your reporting, you want to do it at the day level, but you definitely need a good forecast at the quarter level. If you're doing long-term planning, if you're doing capacity management, you're probably still forecasting at the day level. So that is what you need. Something you should realize that if you go to a finer level, the WAPE will get higher. Is if you look at a day and your forecast is too high and too low, well, that cancels out because you take the sum. And if you take the absolute values at the quarter level, yes, they do not cancel out anymore. Yes, a plus and a minus, because you first take absolute values and then you sum, and they do not cancel out anymore. So the finer the level, the shorter the interval, the higher the WAPE will be. And here I have a small example. I took 5 days around the same profile, some actuals. The forecast is, well, as you see, depending on the day, a bit higher and a bit different, but similar. And what you see are actuals. Some are pretty much around the forecast. Some are a bit off. Not very important here. And of course, it's very easy if you have the data to try it yourself and to see it yourself. If you have a week of data at the quarter level. Here, the WAPE at the quarter level in this particular data set is almost 15%, and at the day level, it is indeed lower, around 12%. So that also raises the question, well, is that a good WAPE? Is that a bad WAPE? And that is also a question that I get regularly. And sometimes people say it should be 5%. And I even some time ago, there was a LinkedIn post by some consultant who said at any level, it should always be 5%. And he had a slogan like 5 is right or something. So what do we think about that? Is that indeed the case? Well, and we of course have lots of experience with forecasting in many different call centers, different types of call centers, very different operations. And it is hard, of course, it is dangerous to give like a single number. And 5 is definitely not the right number. If you can get to a WAPE of 5%, then I think in almost any case, you're doing a very good job. But in certain situations, it's not even possible. And let me try. I will use this slide to try to explain that to you. In the first place, the quality of your forecast depends very much on the amount of data that you have. Yes, if you want to predict an intra-year pattern, perhaps you're in retail and toward the end of the year, you have much more volume, perhaps your customer base is growing and your volume is growing anyway. What is due to the customer base? What is due to the seasonality? If you only want to distinguish these things, you need to have multiple years of data. So if you don't have enough data, then making an accurate forecast gets more difficult. And perhaps you have all kinds of events going on. You have marketing events, but sometimes there is an IT problem, which are not predictable at all when they will happen, and probably neither the volume in it. So that also makes your volume unpredictable. So forecasting, there's always more unpredictability than you expect. And there's even evidence that humans, there's a nice book by Daniel Kahneman, Noise it's called. It's a general book, popular scientific, but definitely an interesting read. Daniel Kahneman is a well-known psychologist, a Nobel Prize winner. And one of the things he argues, he doesn't talk at all about call centers, but lots of other decision problems. Humans have the tendency to overestimate their capability of predicting things. And we see patterns that aren't even there. Yes, that's how our brains work. So we should really base ourselves on the data and on our models, and not think that, and we easily overestimate our capabilities. But there's more to it. Actually, there is a certain level below which you can never reach. You cannot ask, if you're a call center manager, you cannot ask your forecaster, okay, now you are at 8%. I want you to be next year, as a target for next year, I want you to be at 4%. Yes, just do a better job. It's not true that you can get to a WAPE of 0. There is a certain theoretical lower level. Yes, we call that the minimal WAPE. And if you look at one interval, it's then the minimal APE. And there's a nice formula for it. It's the square root of 2 over pi times the forecast. Again, I won't go into the details of that. You might wonder why there is a pi over here. It has to do with the normal distribution, the bell curve you've perhaps heard about, or perhaps you're, because of some statistics courses, you're very familiar with. But anyway, there is some theoretical lower level. You can never get below that. Yes, and this is for one interval. And that is like the average error that you make if you have a perfect forecast. And you can weigh that according to a forecast, and then you get a minimal WAPE for a day. And as an example, again, there are other webinars also on our website that dive more into the details of how calls arrive and where this comes from. But here you see our forecast of that I plotted, that I used earlier. And this one, and as you can see, the volumes are somewhere between 60 and 100. The minimal WAPE here is 8.9%. Yeah, so no way that the WAPE on this volume can get below this number. So this consultant that who posted some time ago on LinkedIn, who said strive for a 5 or something like that, that was really impossible what he suggested. Right? And actually, well, two things. If you look at this formula, you see the forecast in the denominator. So that means the higher your forecast, because you divide by the forecast, the smaller this number gets. Yes? So for high volumes, you get a low minimal WAPE. So if you look at the daily level, at a regular queue, or even weekly level, then this minimal WAPE doesn't play a role. But if you look at the interval level or at small queues, then it starts to play a role. And approximately around a forecast of 250, the minimal WAPE is 5%. Yes, of course, to that you should add the fact that you cannot predict the impact of a certain event, or that you cannot predict certain types of seasonality or other components of your volume. So the total WAPE will be higher than this minimal one, yeah, but can never get lower. So that is important to remember. You cannot go to 0. That is really impossible. Okay, so much for the theoretical part. And we'll put this as 2 separate videos on our website. I want to finish, and it won't take long, but showing you how to calculate the WAPE. And again, there are multiple methods for that. Well, let me show them to you now.